Today we will try to measure RF output power of a transceiver using a dummy load and a RF power sensor. Now what we can see here is a dummy load. This is a dummy load. It is created by connecting 30 numbers of high power resistance in parallel. The total resistance is 50 ohm and it can handle up to 60 watt of RF power continuous. I even tried to give 150 watt to it for few seconds and it can handle that. I mean, nothing happened and it was just fine. So if we want to measure power approximately around 100 watt, we can give the 100 watt for few seconds and we can check the power. But to be on the safe side, or if I want to give a continuous RF power for long duration checking, then we should not exceed 60 watt. And also we have a fan. This fan is taken from a server PSU. This fan blowing air on the resistances and it keeps them cool. Apart from that, we have this is a 12 volt supply which runs the fan, and actual measuring part is here. This is the circuit. These two capacitors and this inductor. These two capacitor and this inductor makes a filter, and these are the, let me show you, these are the diodes. This is a diode. There are 3 diodes in a series connection. See, 3 diodes are there. So these 3 diode and these 2 capacitor and this inductor creates a rectifier and a filter circuit. This rectifier and filter converts the AC RF into DC, equivalent DC. This DC is given to this terminal block, from where we have connected a multimeter. This multimeter is here. This is the multimeter where we have connected it. Now this multimeter will measure the equivalent DC voltage of the RF power, and from that equivalent DC voltage we can calculate the RF output power in a very precise manner, very accurately. We don't need any fancy RF power meter or similar instrument. Okay, I am using this setup. I am using this setup since very long, because initially I found this design from ham radio operator Zulu 33 Tango Z33T. In his website he has described this power meter and how accurate it can be. So I homebrewed this unit and one more unit which is very rugged. It can measure up to 400 watts, but this unit can measure up to 60 watt. So mostly for QRP work. And what I have found is that the measurement is very accurate. It is extremely accurate, in fact more accurate than any commercial power meters like Diamond and Nisi. These meters don't show that much accurately. This meter can measure up to fraction of watt, that much accurate it can be. So let's try it. I have already connected this to a transceiver output. So this is the transceiver and its output is here. This is the output. We have connected it. From here the output goes into the dummy load, and when we try to say something or say make some noise on the mic, and accordingly we'll try to see, we'll see how much voltage it will show here. From that voltage you will calculate the RF output power. So let's see, for example, so let me try to take the PTT. Here is the PTT. Let's see, the multimeter is set on the 50 volt range, so we should see at the 50 volt scale. And here I have selected the low power mode, so the transmitter output power will not cross 25 watts. So let's see what happens. Hello. 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 So it is approximately 38 volt. 38 volt. Let's see how much the 38 volt DC voltage equivalents to how much RF power. So we'll keep the we'll take a calculator and we'll try to find out the RF power. So let's try to calculate the RF power. These are the three formulas which we need to calculate the RF power from the voltage, DC voltage. Here the VP, we need to find out the VP first. So VP will be Vm plus 0.5. Vm is our measured voltage and the voltage was 38 volt plus 0.5, that makes 38.5 volt. Then we can calculate, this is the calculation. Then from here we can calculate the VRMS. So VRMS will be, pardon me, it is very difficult to make a video and write at the same time, so I might miss the point of focus. VRMS, I need to find the VRMS equal to VP by root 2, that makes 38.5 by root 2. Let's calculate this. 38.5 by root 2. 38.5 by root 2, that makes you 27.22. So equal to 27.22. Now from there I need to calculate the RF power. So P RF equal to 27.22 square by 50 equal to, so 27.22, this much square, so we'll put square this much by 50. So it's approximately 14.82 watt or 15 watt approximately. So we can write 14.82 watt or roughly equivalent to 15 watts. This is very accurate value. So our transmitter power in low mode at 20 meter band is 15 watt. Now instead of doing this whole calculation every time in a paper with a calculator, what we can do, we can create a graph, and from that graph we can calculate instantly, or in fact we can create a lookup table. So we have what I have done, I have created an Excel sheet. In that sheet we have the graph and the table. From there we can calculate instantly. Let me show you that graph. So this is the graph that I have created in Excel, and this is the table. In this table we have voltage and RF power. Okay, so if we plot this table in this graph, we have x-axis the DC voltage and in y-axis RF power. Okay, so in our measurement the voltage was 38 volt, so let's place this on 38 volt. 35, so somewhere between this and this, 35 and 40. So it's let's consider it's close to 40. So it's approximately 16 watts. Okay, so this is the way we can measure the output power of the transmitter. In fact, we can to make it more accurate, we can change the voltage levels in this table. Like in this table I have given 5-volt intervals, but we can even make a table with 1-volt interval. In that case it will be more accurate. That can be done. That's not a difficult task. You can create any chart, change the chart in the Excel at any point of time. So this is the best method, I think, for measuring the power of a transmitter. But it's not, I mean, it is suitable for occasional measurement only. I mean, when you are doing some testing or construction or home brewing, you want to measure your output, measure the output power of your newly built transmitter, or you are testing a transmitter. At that time, this method of measurement is very accurate and very handy, and you don't need any expensive measurement equipment. So that's all from me. 73, and bye bye.